This lecture covers a part of optimization called linear programming problems. What is meant by a linear programming problem and how you can formulate a linear programming problem and what are the stages in the formulation and how you can solve a linear programming problem. So we can discuss all these things in this lecture. So in this, what is meant by linear programming problem? So that is the first thing. Now, if you have a raw data, means initially we don't know a set of equations. We have only the raw data. Raw data means we have certain information only. So with the help of information, we cannot do anything. Once if you convert that information into a set of mathematical equations, then only we can do something. We can find something. So if in this process of converting the raw data into a set of equations, if all the variables of the problem are linearly related, such problems are called the linear programming problems. And this linear programming is one of the simplest way to perform the optimization. So see, actually in any case of optimization or in any case of problem or in any case of process, the ultimate goal or ultimate objective is either maximize something or minimize something. Means we have to maximize profit, or we have to minimize loss, or we have to maximize revenue, we have to maximize efficiency, we have to minimize the cost, we have to minimize the loss, or we have to minimize the error. So like that, ultimate aim or the goal of the industry or process or maybe any college or etc. etc. So ultimate aim is either maximize something or minimize something. So optimization is nothing but maximize or minimize something, means function. Let us take a function f of x. This f of x we have to maximize or minimize. So that is what the optimization. So you have to maximize, either you have to maximize or you have to minimize. So that is the ultimate goal of any process. To identify the maximum value or minimum value, we can take this linear programming process or the linear programming problem as one way. And first, how you can take the raw data, how to convert the raw data into a set of mathematical equations or inequations where all the equations and inequations are linearly related, means all the variables power should be equal to 1, right? So actually this will give you the decision making. How? Because we have raw data, a manufacturing industry is there. We have to tell how many units they have to manufacture in order to get a maximum revenue. A manager should give that decision, right? So for example, an advertisement company is there. So how many ads they have to provide so that their product will reach to maximum people. So such type of decisions we have to provide with the help of this problem solving. So such type of decision making is possible with the help of this concept. And on the other side, we are going to maximize the solution or we are going to minimize the solution, because that depends on the objective. So if the objective is a maximize, then our solution will maximize the function. If objective is minimized, then our solution will give the minimum value. So we have different solutions. Out of n number of solutions, we have to pick a best solution that may maximize the function or that may minimize the function. That depends on the objective, because if the objective function is a cost function, definitely that should be minimum. If the objective function is a profit function, then that definitely it should be maximum. So like that, we have to find whether the function is a maximize or something and minimize something. That depends on the nature of the function actually, right? So if the nature of the function means if the profit function, definitely have to maximize. There is no doubt about it, right? So ultimately, once if you know that function, the approach, not only linear programming process, so any other approaches. Finally, after certain steps, we are going to identify a best solution and a feasible solution which may satisfy all the conditions and which may satisfy all the constraints of the problem and which may give a best feasible solution or best solution among the possible solutions. So all these things are possible in the optimization, right? So how you can form actually in this, when we have raw data, the raw data means certain information is there. So what type of materials are required to manufacturing a certain product, and what are the type of machines we have to use to manufacture the product, and how many persons are involved in the manufacturing process. So all this information is included in the raw data. With the help of that raw data, now we have to convert that raw data into a set of equations, that is set of mathematical equations. So if you convert that raw data into set of mathematical equations, then it is called the formulation. That is what the mathematical formulation. So this mathematical formulation involves 4 steps. In that, the first step is the selection of variables. So what is meant by selection of variables? See, so actually your profit will depends on the number of products, because we don't know how many products we have to manufacture. We know the information of the man available and the machines available and the time and the raw material available and the conditions. We know all this information, but we don't know how many units we have to manufacture in the given time. And we know how much profit we will get for each unit, but we don't know how many units we have to manufacture. So we have to identify such type of variable in the raw data. So that is what the selection of variables. That is the first step in the LPP formulation. So in the raw data, you have to identify what type of variables are there, and you have to select the variables, correct variables you have to select. And these variables are called the decision variables, because ultimately your profit or loss or efficiency or error, whatever it may be, so those values depends on these variables, because you are getting 1 rupee profit per unit. If you make 10 units, you will get 10 rupees profit. So definitely you have to give that decision, how many units you have to manufacture. So that is what the decision variables, because the decision making is nothing but you have to tell the number of units. So that is what the decision making, right? So these variables are called the decision variable, because this is what the final decision you have to provide to get the maximum profit or to get the minimum loss. So that is the first step in the formulation of LPP. So selection of variable. And the next step is setting of objective function, because I already mentioned. So if the goal of the manufacturing company is getting profit, it means, for example, have 2 type of products in a company. In each product, for example, I have 2 type of products, A and B. For example, if I consider the A product, so that A product will give 1 rupee cost per unit. So sorry, 1 rupee profit per unit. Whereas B will give 2 rupees per unit. So means if you make 1 unit of A, you can get 1 rupee profit. So if you make 10 units, you will get 10 rupees. If you make 20 units, you will get 20 rupees. Similarly for B. Now, your entire profit will depends on the number of units of A as well as B. So you have to write this relation as an objective function, because ultimately this function should be maximized. So I already mentioned the objective function or the optimization is nothing but maximize something and minimize something. Now therefore, so in this case you are getting 1 rupee per unit for A, means if you make X units, definitely you will get X rupees. If you expect 2 rupees on 1 unit for B, then if you make Y, definitely the profit will be 2 into Y together, because in manufacturing company you have to do both A and B. You have to manufacture both A and B. So together A and B together will give you a profit of X plus 2Y. Now that is what your objective function. Now see, the entire raw data I have a product A for 1 unit, I will get 1 rupee profit. I have product B for 1 unit, I will get 2 rupees profit. This is what the raw data, only information. That information now we are going to convert that into an equation like x plus 2y. So that is what the formulation means, converting the raw data into a mathematical model. So this is the second step. You have to set the objective function. It may be a maximize something or minimize something. Definitely the objective function is of maximize something and minimize something. But you see, if you compare A and B, you will get maximum profit on B, not on A. But in the manufacturing process, you will get both products. You cannot avoid A because you are getting maximum profit on B. So ultimately your preference will be B. But in that way, you cannot avoid A because together you are getting. So therefore, there are certain constraints on A and B because again, these two are manufactured with the help of 3 machines, with the help of 4 technical persons, with the help of 2 type of raw materials. So using 2 type of raw materials, you are getting 2 products. By processing on 3 machines, you are getting 2 products. Means you cannot avoid one product. And if you take one machine, there is a certain time condition on the machine. You cannot run the machine 24/7. You may run 12 hours, or you may run 8 hours, you may run 16 hours. Because again, that machine operation will depends on the expect. He may be available for 10 hours, then you can run only 10 hours. So certain type of conditions are there, certain type of limitations are there, certain type of requirements are there. So you have to impose all these requirements and the conditions, availabilities in the formulation. And that is the third step, identification of constraints. Constraint is nothing but what is the requirement there for product manufacturing. What is the availability of raw material? What is the availability of machine? What is the availability of manpower? So all these you have to include in the problem, because that raw data you have to include in the problem. So that is the third step. Finally, conditions on variable. This is quite easy because you are taking products. So the products can't be negative. So you cannot search the solutions in the negative region. Only you have to search the solution in the positive region. That's it. So therefore, it is quite easy to write the conditions. So these are the 4 steps in the formulation of LPP. The one step is selection of variables. And the second step is setting of objective function. The third step is identification of constraint. And the fourth step is conditions on variables, right? I think you are clear now. So let me take one problem. So with the help of one problem, we can get the mathematical model. So once if you get the mathematical model, we can adopt different mechanisms, different methods to solve the problem or to find the solution, right? Let me take one problem. So this is the problem. So I'm taking similar manufacturing problem. So let us take a particular company manufactures 2 brands of products. So let us take 1 and 2. Now, how the raw data will be there? Now, how the information will be there? Now, see, so actually, these 2 products, if you want to manufacture these 2 products, we have to operate 3 machines. The 3 machines are lathe, milling, and grinding machines. You have to operate 3 machines. Now, if you make 1 unit of product 1, means 1 unit of product 1 will give you a profit of 45 rupees and requires, that is the requirement, means I cannot use 3 hours on lathe machine because 2 hours is enough to make 1 unit of product 1. So therefore, that is what the requirement of lathe machine, 2 hours on lathe machine. So 3 hours on milling machine and 1 hour on grinding machine. Similarly, for the second unit also have profit information and the requirement information. And I cannot use the machines 24/7 because I have 7 days in a week. So for each day I have 24 hours. So the total number of hours in a week is 24/7, right? 24 into 7. But I cannot use 24 into 7. I can use only 50 hours. That is what the prior requirement. Maybe the run purpose, we may take the missions, and maybe the availability of the skilled person. So there are several additional conditions. So based on that, I can use the machine up to 50 hours. So like that, other conditions are there for the other machines, milling and grinding. So if you have such type of raw data, how you can convert the raw data into a mathematical model? So here the linear programming problem. So again, you have to follow the 4 steps I already discussed. So with the help of the 4 steps, ultimately you have to convert the entire raw data or the entire information into a set of equations. How you can convert? Now see, so take the first step, that is the selection of variables. In case of selection of variables, how you can say select the variables? So let me change the color. So for each step, I will use one color. Now here the profit will depends on the number of units of product 1 and the product 2, because ultimately the manufacturing company will produce 2 type of brands, brand 1 and brand 2. Now I know the profit on 1 unit, so I don't know how many units I have to manufacture. Therefore, let us consider X be the number of units of product 1. I will highlight like this, okay, instead of writing. And Y be the number of units of product 2. Right. So this is what the first step. I don't know how many units we have to manufacture. So therefore, ultimately we have to give the value of the number of units of brand 1 and brand 2. That is what the decision makes. That is what the final solution. So that is what your initial step also. So you have to identify the variables. So X and Y, these are the decision variables, because your profit will depends on these variables values. So X and Y. Now this is our, we identified the variables, decision variables. So the number of units to be manufactured, number of units of brand 1 to be manufactured is X, number of units of brand 2 to be manufactured is Y. Now the second one, we have to write the objective function. Now what is the objective here? So what information we have? We have profit information. So let me take another color. We have profit information. So if you take 1 unit of brand 1, we will get 45 rupees profit. For 1 unit, we will get 45. Now, how many units we have to manufacture X units? So therefore, the profit on brand 1 will be 45 into X, because 1 unit will give 45 rupees, means the X number of units will give 45X. Simple. Was 1 pen cost is 2 rupees. If you need 10 pens, 10 into 2, so that is 20. So X and 45 into X, that's it. Now similarly, the 1 unit of model 2 will give 70 rupees profit. Now we are going to make Y number of units. So the total profit on product 2 will be 70 into Y. Now this manufacturing company will manufacture the 2 type of products, 1 and 2. So therefore, the profit on 1 and the profit on 2, together the total profit will be profit on 1 plus profit on 2. So that is what, 45X plus 70Y. So this is what the objective, but the objective is a profit. So you have to, ultimately the objective function should be either maximize or minimize. So it is a profit function. Therefore, it should be maximize. It should be maximize. That's it. So the second point is also our. Now initially we selected the variables, and now we set the objective function. The third one is the constraints. The third one is constraint. Now I have 2 type of products. Now these 2 type of products should go operations on 3 machines, so lathe, milling and grinding. Now look at the processing times. For example, if you take the lathe machine, the 1 unit needs 2 hours on lathe machine, but I want to make X units. So if 1 unit required 2 hours, X units required 2 into X. So this is what the number of hours on lathe machine for product 1. Similarly, 3 hours for product 2 for 1 unit, but I want to manufacture Y number of units. Therefore, it becomes 3 into Y. So these are the total number of hours for both products together on machine lathe. But see, so this is the total number of hours. These total number of hours may be 20, 30, 40, etc. Depends on the values of X and Y, but it should not go beyond 50 hours. So the maximum value of this should be 50. Therefore, it is less than or equal to 50. This leads to one constraint. Similarly, that is for the lathe machine. If you take the milling machine, the information is 3 and 5. So, right, just you vary the coefficients 3x plus 5y. Again, the restriction. So that is a maximum of 110. So less than 110. So this is what the constraint on the second mission. Similarly, for the third, it will be 1 and 4. So these coefficients will vary only. 1x plus 4y. Again, the condition is less than 100. Now I have 3 missions in the problem, so I will get 3 constraints. Only 3 constraints for the 3 missions. So this is what the third step in the formulation. Finally, the fourth step will be the conditions. Here, I want to make the number of units. So generally, number of units can't be negative. They are always positive. So therefore, these values of x1 comma x comma y should be greater than 0. Should be greater than or equal to 0. At worst condition, they may be 0. They may be 0. Means we are not getting any profit. We are not getting any loss. So that is the worst solution among the best solutions. So x comma y is greater than or equal to 0. That is what the conditions on variables. So like that, in any information you can convert in such type of mathematical equation. Now look at the equations. Your objective function and all constants are linear equations or inequations, because x power 1, y power 1 in all cases. So therefore, this type of problems are called the linear programming problems, right? So they are the fundamental process or fundamental concept in case of optimization. So most of the problems are linear in nature. If you take complex problems, you will get nonlinear equations. But all these manufacturing related problems are advertisement related problems. So mostly transportation related problems or assignment related problems. So all these problems are linearly related, right? So if you take any problem, you have to follow these 4 steps. First, you have to select the variables, and then you have to write the objective function. And finally, third step, you have to write the constraints. Finally, you have to identify the conditions. So if you do this, so then you will get the maximum marks in the exams. So this is the way to solve a linear programming problem formulation. Once if you know these equations, so solution, you have several methods, mathematical methods. So using mathematical methods, you will get the solution at what value of x and y you are going to get a maximum profit. So that you can find with the help of some approaches. Okay. So in the later classes, we can discuss that. Thank you.